Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In my last video, I repaired this power supply. It is AY250P4HF01. It is for LCD TV power supply. While repairing, I found this MOSFET set short circuit. I removed this MOSFET panel and I turned on the power supply with bridge rectifier. And after that, using a sequence, I verified different circuits. At the end, I installed this PFC panel and then I tested a final test and we repaired this power supply. And I received a comment that while repairing, how you know that without these MOSFETs, how you turned on 5-volt power supply. That was standby voltage. So let's see the function of this power supply, how it is working, and then it will become easy. This power supply, I can say, it have different sections. The first section that is EMI protection and rectifier section. This rectifier section will take AC voltage and it will rectify this voltage and it will provide to this capacitor. Let's make block diagram here. Here we have line and neutral. This is our protection circuit. EMI, overcurrent, surge protection, everything is here. Then we have a rectifier section. Bridge rectifier and so on. Then we store these voltage on this capacitor. That is here. Because this power supply is used to drive LCD backlight and it consumes too much power. And if we turn on this power supply for all the time, that means it will consume the power every time. To save the power, this power supply is divided into some portions. Then this voltage will reach to this power supply, this small section. That is called standby section. It will provide us 5-volt SB. It is working like similar to a mobile charger circuit because it will provide a very little amount of current and this signal will just only power on the motherboard of the TV set, and when we will press the remote or we will press the power on key from the button menu, at that time these 5-volt standby will provide to PSON command, power supply on command. We can say we have another power on button here. When we will feed this supply, this 5-volt section to motherboard, and this will provide a PSON command, power supply on command. We can say this 5-volt will reach to the power supply again here. At that time, from this point it will receive a power on command. Now we need to understand the function of this circuit. When we applied power to standby section, so this section can operate from 85 volt to 265 volt AC. When the input voltage are within this window and we applied here line and neutral, this section will remain on because it is not providing too much power. It will take just only the applied voltage and a very small circuit here, SMPS controller, that is here, SMD 6-pin IC, and it will drive this MOSFET here, that is this one. So this 5-volt section this optocoupler for regulation. So it will provide regulated 5 volt through this rectifier, and we will take output. It have its own TL431 and regulator, and it will provide regulated 5 volt standby. When we want to turn on, as I discussed, that this power supply provides heavy amount of power. For that purpose, there are two techniques. If we have a voltage here 85 to 265 volt AC RMS, if we rectify this voltage at that time, this SMPS controller, it will drive MOSFET and it will provide to the transformer, and it will provide output here. When the voltage will drop, it will increase its duty cycle to provide rated output. Or if the output will increase to maximum, and we can say normally it is working at 265 volt and the load is full, it will increase the duty cycle. So in both conditions, either there is line variation or load variation, this SMPS controller will adjust its duty cycle. It is non-PFC based. In PFC based, input line voltage, what are there? 85 volt to 265 volt. It will provide 400 volt DC. Here, these voltage were varying from, we can say, 110 volt DC to 340 volt DC. So within this voltage range, this SMPS controller IC will adjust its duty cycle, turn on time, VS turn off time. But here we provided easiness for this IC that it will not take care for the input voltage. To maintain this voltage, we used PFC circuit. Then this IC will just monitor the load. So here the circuit will provide good efficiency and it will long life. When PSON command will reach here, it will turn on this PFC circuit. So in PFC circuit we have a coil here and we have some MOSFET here. It is connected to ground. Then we have rectifier, and here is the capacitor. Normally when this circuit is not powered on, the rectified DC voltage will reach here. From the rectifier DC voltage, whatsoever, we can say from 110 volt to 340 volt DC, these will reach directly to turn on this standby section. But when we need to turn on main section, this signal will go to this PFC controller and it will monitor the voltage here. It is as a feedback. How much voltage are there? It will monitor the voltage and it will adjust its duty cycle, and it will make a surge on this DC rail to generate a magnetic field. After that this will off. When it will off, this magnetic field will collapse and it will become in series with the line voltage, rectified line voltage, so it will boost the voltage. We can say it is a voltage booster. Before this, the voltage were passing from 110 volt to 340 volt, but now the voltage will be maintained at 400 volt DC. Now, the same voltage will come to this PFC on command is reached here, and this command is also reached here to secondary power. So this power controller, now it will turn on and it will provide the outputs. We will take these outputs in the second side and it will provide regulated outputs. Now this PFC circuit it will boost the voltage and it will maintain the voltage at our required limit, so that this IC will work freely to maintain the output load. Let's check this circuit. Because this circuit don't have any service manual, circuit diagram on the internet. If any circuit you are working, you don't have any circuit diagram or anything, locate the IC, check the part number of that IC and go to internet, go to Google. When you download the datasheet, you will find application note, application example. So here it is using L6559. We can say it is around 90 to 99% same as our circuit. I downloaded two different data sheets. One is here, the second is here. Maybe in some circuits it will like this, in some circuits it will work like this. So when we will find this circuit, it is half bridge driver, so it will give a clear concept about the circuit. This is our secondary section power supply, and this is NCP1653. It is boost converter, PFC controller. We can see it have 15 volt VCC and it have a drive, it have a MOSFET here. We have this inductor here. The rectified voltage will come to the inductor, and then we have MOSFET here. When this IC will turn on, it will make a surge because this line is connected to capacitor ground. So it will take a surge, heavy magnetic field will build here. After that, this IC will turn off. When it will turn off, for example, this is the one condition. It will turn on for a small time. If the voltage are decreased at this point, that is PFC output as we discussed here. At that time, maybe it will increase its duty cycle like this. So it will make more strong magnetic field, so that more strong magnetic field will induce more voltage. So we can say we added one generator here in the series of the line voltage. So it will compensate the line variation so that this IC will work freely without any disturbance. So our power circuit will work normally. So this is the application note. This is one diagram for this PFC circuit, and here is another example for this PFC circuit. And this is the internal structure of this IC, how it is working. So it is the easiest solution when we don't have any circuit diagram. Just only find the part number, download its datasheet, and you can find what is in the circuit. If we check here, line and neutral. Here, then this line throw fuse. I installed a bus fuse wire. I will arrange the original fuse 6.3 ampere fuse, and I will install here. So this voltage will reach here. After that, we have a filter capacitor here, class X capacitor. Then this voltage will reach here to the dual line filter. Then these voltage are reaching here to the second stage filters. After that, these voltage are reaching to this bridge rectifier, and the same voltage, these are going to these resistor network, and these voltage are reaching to this circuit that is here. It will provide a startup circuit to our standby section. From this network, we will take a first start to power on this section, and the same rectified voltage are reaching here through this jumper here, and these are reaching to this transformer. This is our standby transformer. Here is the MOSFET. So these voltage, negative voltage from here and positive voltage from here to the transformer at this point. So this section will provide 5 volt in the output. When we will find 5 volt in the output, when we will provide PSON command, this first optocoupler for this circuit. If this circuit is damaged, what we can do, we can take an external 5 volt using any we can say mobile charger or any small module 5 volt converter from 220 volt to 5 volt converter. So that will provide standby voltage. When our standby section is ready and we want to turn on PSON command, this command will reach here to this optocoupler, and this optocoupler will switch the 15 volt generated by this transformer auxiliary winding. That 15 volt will switch from this optocoupler. When we applied turn on command, PSON command, this optocoupler will pass this 15 volt from this rectifier and it will reach to this point, and this is reaching here at this IC. This resistor 4.7 ohm resistor was damaged, so I installed this resistor and circuit started working. In the first step, as I discussed here, when we will provide PSON command, PFC circuit will start. When it will start, it will make a boost. At that time, this section will start working. If the voltage are less than 300 volt, this will not start. It will wait until this transistor will turn on and it will receive PFC on verification that PFC is turned on. At that time, it will start to switch and it will provide drive signal to these MOSFETs 1 and 2. These two MOSFETs will start switching. At that time, we will receive drive to this transformer. This transformer will provide output, and rectifiers, this rectifiers will provide output. And here we have two different optocouplers. Here is TL431 for both sections 1 and 2. This optocoupler and this one. This is for overvoltage protection and this is for regulation. If we have fluctuation or anything, at that time we need to verify this section. When we were repairing this power supply, in the first step I installed the bridge rectifier here. We entered 220 volt rectified and provided to this capacitor. At that time, no need to use MOSFETs and rectifier, and it will turn on 5 volt standby in the output section. When we need secondary power, at that time we need PFC section. If the voltage are less than 300 volt, at that time this secondary section will not turn on. If the voltage are above than 300 volt, it will turn on directly. If the voltage will drop, at that time, this is our positive line of the capacitor, so this line will reach here and it will provide the voltage value to this NCP1653, and it will adjust its duty cycle to turn on, turn off, to adjust duty cycle these MOSFETs. So this is the working principle of this board. I hope so you enjoyed this video. If it is good, hit the like button. If you have any questions, write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.